Hi, welcome back to my video series on similar figures. This is the second video in the series. So the first one we talked about defining what it means for two figures to be similar and what we would need to show in order to prove that two shapes are similar. So if you haven't taken a chance to taken a minute to watch that video, go watch that video and then come back so you can see how we're going to show what we need to show. Okay, so the question for this problem that we have on the screen here is, are these shapes similar? Yes, technically that is a yes or no question, but we don't want to just guess at it. Yes, they look like they could be similar, but we don't know that for sure. So we need to go about showing that. And if you recall from the last video, the first condition that we had to prove was that all of the corresponding angles are congruent, which means that I need to be able to connect an angle in figure 1 on the left with an angle on figure right on the right that has the same angle measure. Looking at this example though, we can see that all of these angles have little red boxes in them, which means they are all 90 degrees. So I can connect I, J, G, and H from the left figure with any of the angles in the right figure. So I'm going to say, to answer the question down here, congruent angles, yes. All of the angles match, so they are all congruent to each other. They are all 90 degrees. So all are congruent to each other. Okay. If you were doing this problem on paper, I would expect that you would actually write this out or write out the similarity statements. Okay, because we are not just looking to answer a yes or no question, we are looking to not only answer that question, but also show why our answer is justified. If we say that these figures are yes, we need to have the evidence to back it up. Okay, that's answering this congruent angles question in pink and the proportional sides question in purple. Okay, so the proportional sides, that's the second condition for proving that two figures are similar. We have to be able to set up the side fractions to be able to show that these are in fact similar. Okay, we are dealing with rectangles here, so if I wanted to go ahead and write in some values, I know with rectangles that the side opposite of this 40 foot is also going to be 40 foot. And I'm going to have 25 feet at the top of the left one because it's opposite of the other 25. And then looking at the other figure on the right, across from the 20, we'll get another 20 feet. And then 32 across from 32. Okay, so now what we need to do is set up the fractions. Okay, if you're unsure on what I'm doing, I would again encourage you to go back to that last video where I did show you and set up how to do these proportions. Okay, so we have a four-sided figure here, or two of them rather, so we're going to set up four fractions, one to represent each side. Okay, I'm not writing any equal signs between them or anything because I'm looking to show that those are proportional. So the first thing I want to do is set them up, and then I want to show that they're the same before I go back and say, okay, these are in fact equal, which satisfies the proportional sides requirement for similarity. Okay, so looking at this, I'm just going to go ahead and use the left figure, the JG figure, as my top numbers for my fractions, and then use the NOLM figure as the bottom numbers. And again, just like in the last video, I'm going to go smallest to largest, but we do have duplicates, so that's going to be fine. We're going to do 25, another 25, 40, and 40. Again, I'm using all the numbers from the same figure on the top. And then I'm going to go with 20, 20, 32, and 32. Now, looking at this, I can already immediately say that 40 over 32 is the same as 40 over 32, and 25 over 20 is the same as 25 over 20. What I need to show is that these two are in fact equal to each other. I need to show this right here, okay? So I need to reduce my fractions. Again, use the calculator for this. 25 over 20 is going to reduce to 5/4, and 40 over 32 is also going to reduce to 5/4. So now I can write in my equal sign, which means I can also write in my equal sign above, and now I can say that all four fractions that represent the sides are equal to each other. So that is satisfying the question, are the sides proportional? If I set up fractions connecting the sides from the two figures, are they equal to each other? And the answer to that question is yes. Okay, so since we were able to answer yes to the congruent angles question and yes to the proportional sides question, then we can say these are in fact similar. Yes. And we can go a little further and we can actually write our similarity statement. Okay, so for the left figure, I think I'm just going to go H, I, J, G, and then my similarity symbol. If you don't know what that symbol is, go back to the last video. HI was a 40 length, which is going to relate to a 32 length. So I'm going to start with M, I think. I'm going to go M, N, O, L. Okay, so H is congruent to M, I is congruent to N, J is congruent to O, and G is congruent to L, and then so on and so forth. Okay? All right, let's look at a second example. These shapes are a little bit different. They're not rectangles, but we still have a four-sided figure, and we still are looking to prove the same two things. Can we connect all four angles and show that there's a congruent match? Okay, so I'm looking at this and I see C, D, E, F for the left figure. So maybe I'll just write that up. Go back to pink for this. Angle C, angle D, angle E, and angle F. And I need to be able to write a congruency statement. Remember, congruent is an equal sign with a squiggle on top. Okay? Now, I don't have any angle measures in this, and I don't have any boxes, but what I do have are red arcs. Red arcs. These red arcs that only have one match to angles in the other that also have one. Okay, that's how we tell them apart. We can say that angle C and angle D and angle M and angle N are identical, but they are not the same as F, E, P, and O. Now, because F, E, P, and O all have double arcs, all of those are going to be equal to each other. So even though I don't know what the exact measure of those angles are, I do know that there's a congruent match. So I can say that angle C, maybe I use angle M for that one, angle M. All right, angle D is going to match with the other single arced angle, which is going to be angle N. And then E is a double arc angle, and it looks like I'm going around in a circle, so I did C, D, E, F, and then I started with M, and I'm going M, N, O, P. Okay, so I am just going to go ahead and write angle O and angle P. Okay, so to answer the congruent angles question, the answer is yes, all of the angles have a congruent match in the other shape. I've satisfied the first condition of proving similarity. Okay, I still have to figure out the proportional sides. Okay, so again, we're dealing with a four-sided figure here, so we're going to deal with four fractions. I'm going to go ahead and use the values on the left side for the tops and the right side for the bottom. Okay, and then we're going to go smallest to largest. So I see a 24, two 26s, and a 37. And then in the other figure, I get 16, 2 26s, and a 29. Okay. Now, looking at this, I have two identical sides already. I have the 26 equals to 26. I have to be able to show that all of these are in fact similar. However, looking at this, I know that 26 over 26 is the equivalent of 1. However, 37 over 29 does not equal 1, and 24 over 16 also doesn't equal 1. Okay, so what I'm showing here is that even though I have 4 congruent angles, I don't have all my sides matching up. Okay, so these don't match. These don't match. So, to answer the question, are these shapes similar? The answer to that question is a resounding no. And it has to do with the fact the sides failed to meet the condition. Okay? So I can't write a similarity statement here. I just simply answer no. And the evidence to back it up is what we showed down here in purple and green, that these fractions are not the same, so therefore these shapes are not similar. Okay? That is proving that two shapes are similar, yes or no, and writing some similarity statements. Please check out the next video in this series for some more examples on how to do other types of problems.